Standard enterprise data loss prevention tools operate on predictable algorithms. A conventional DLP filter successfully intercepts and stops basic patterns, like social security numbers or credit card formats, before they leave the corporate network. The perimeter breaks down when employees encounter friction. To complete tasks, workers bypass approved network configurations, pasting internal documents and code directly into public AI platforms, a practice known as shadow AI. Off-the-shelf DLP is blind to these workflows because it cannot recognize contextual PII or custom internal secrets. While standard identifiers are blocked, unique internal project codenames, API tokens, and bespoke database schemas slide right past perimeter filters. Once they clear the boundary, they're ingested into external LLMs, written into server logs, and become available for model training. Because this proprietary data doesn't match the regular expressions monitored by IT, security teams receive zero alerts that an exfiltration event has occurred. Relying on generalized DLP for generative AI workflows creates an invisible exfiltration vector, exposing an enterprise's most valuable intellectual property without an audit trail. The conventional enterprise response to data leakage is to route all outgoing AI traffic through a centralized cloud proxy. The proxy acts as a checkpoint to inspect payloads before they reach the LLM. This setup introduces a man-in-the-middle vulnerability by design. By diverting sensitive data to a proxy vendor node for sanitization, the enterprise simply shifts exposure risk to another third-party vendor. Inspecting massive prompt payloads at that node creates severe latency, resulting in unacceptable delays for the end user. Securing generative AI requires moving the security perimeter away from the cloud entirely. We define this structural methodology as Zero Trust Data Sanitization, or ZTDS. This architecture model illustrates the core rule of ZTDS. By collapsing the perimeter down to a single local laptop node, sensitive data is scrubbed before any network request is ever initiated. Mechanically, this localized scrubbing executes entirely within the browser's volatile realm, replacing raw data with irreversible tokens. By executing strictly in local memory, 0 bytes of raw PII ever touch a network packet. Only the anonymized tokens stream out of the machine. Processing entirely in local memory means there is no round-trip server communication, adding zero API latency to the user's workflow. ZTDS establishes a memory-level barrier inside every employee's browser. It ensures that only sanitized tokens enter the network buffer, keeping raw data restricted to the local device memory. Deploying a localized architecture presents an immediate technical hurdle. A local engine must identify highly specific contextual data instantly, without pinging a cloud-based threat database. The ZTDS engine solves this cold start problem by deploying with pre-built industry profiles directly in the browser payload. As shown in this security control panel, organizations can instantly activate distinct toggleable targeting parameters for legal, finance, healthcare, HR, and DevOps sectors. The legal profile applies specific regular expressions to instantly recognize attorney-client privileged information, like case numbers and judge names, processing the redaction locally without needing to query a server. In the finance profile, the engine executes loon-aware detection logic to secure credit card numbers and IBANs directly within the browser's memory footprint. Switching between these complex detection profiles happens instantaneously, utilizing the local CPU rather than relying on network bandwidth. These localized profiles eliminate the blind spots of generalized DLP, delivering immediate, sector-specific protection without incurring cloud latency. Standard industry profiles cover the baseline, but CISOs must also protect highly specific proprietary data formats that no out-of-the-box system can anticipate. This is addressed through the Custom Regex engine, a feature allowing security teams to define their own targeted data identification patterns. An enterprise can input custom regular expressions specifically engineered to target their internal project codenames, unique UUIDs, or bespoke AWS API key formats. This parsing diagram demonstrates the mechanics. A raw, complex, proprietary string is instantly snapped into a bracketed token within the strict boundaries of the local machine. Because this logic executes entirely within browser RAM, the regex rules are never exposed to the cloud. This tokenization preserves the semantic structure of the prompt. The LLM can still read. the context of the sentence and deliver an accurate response, while the actual internal secret remains hidden. The Custom Regex engine provides security teams with a surgical tool to secure unique intellectual property directly at the keyboard, bypassing the limitations of standardized security routing. Security leaders are rightly skeptical of software vendors promising zero-server operations. Trusting a privacy policy is insufficient for regulatory compliance. ZTDS provides a verifiable architectural proof through airplane mode verification. To truly test the system natively, a user can completely disconnect their device from Wi-Fi, severing all internet connections. Even while completely offline, the local engine perfectly identifies and tokenizes complex proprietary data streams inside the browser. Compliance auditors can open their network inspection tools during the tokenization process and verify that exactly 0 network packets were dispatched. This offline verifiability replaces trust but verify with direct technical evidence. It provides auditors with the specific packet-level data required to satisfy strict compliance mandates without relying on vendor promises. Restrictive IT policies attempt to solve data leakage by banning generative AI outright across the enterprise. Blanket bans do not stop AI usage. They simply drive productivity onto unsanctioned, unmonitored shadow networks where IT has zero visibility. Security teams must shift their mandate. Instead of restricting access, the goal is frictionless empowerment. This protected interface demonstrates the end-user experience. ZTDS acts as a seamless, invisible guardrail, allowing employees to leverage public AI models without breaking their concentration or slowing down their workflow. This localized approach provides the processing speed of generative AI alongside the security profile of an isolated sandbox. By adopting zero-trust data sanitization, enterprises stop fighting their employees and start securely utilizing AI to outpace their competitors.